Hi there, this is my Google presentation on the Muscular System Unit 1 by Ben Woodford. Muscular System, major muscles. As you can see here, this is a diagram of some anterior skeletal muscles and some posterior skeletal muscles. The anterior skeletal muscles include the abdominal muscles, the pectoral majors and the quadricep. And the posterior skeletal muscles include the latimus dorsi, the gluteus maximus and the rhomboids. On these slides here, I have done a table of all the locations, insertions, origins and functions of the muscles in the body. For example, the obliques, their function is lateral flexion of the trunk, the location is the waist, the origin is the pubic crest and the iliac crest, the insertion is at the lower 8 ribs, and movement available here is the oblique curls. Types of muscle. There are 3 types of muscle. These are cardiac, skeletal muscle and smooth muscle. Skeletal muscle is the type of muscles that attach to the bone, for example, deltoids and pectorals. This type of muscle is used for movement and it's voluntary, so therefore it's up to the brain to send signals to the muscles to be able to do this movement. This type of muscle is used for exercises such as bench press. The skeletal muscle is striated. This means that it's a sarcomere and is used for muscle contractions. Well, that's used for muscle contractions. Smooth muscle. This is found in the walls of organs except for the heart. For example, the small intestines and the stomach. This muscle is used for things like digesting food. This muscle is involuntary. This means that the body does it naturally without you having to think about it. This muscle does not have a sarcomere for contractions as it is not striated. Cardiac muscle is found in your heart. This muscle contracts so your heart can pump blood around the body to all the muscles. The muscle is involuntary. This means that your brain doesn't have to cause the use of this muscle, so therefore your body does it naturally. This muscle is striated. That means it does have a sarcomere which is used for its contractions. Muscle fibre types. There are 3 types of muscle fibres. These are type 1, type 2A and type 2B. Type 1. These muscle fibres are slow twitch muscle fibres. These muscle fibres are red because they have a lot of oxygen through red blood cells and high numbers of mitochondria. Due to this, they don't tire very easily, and this means that the muscle fibres can do many small muscle contractions because they have a lot of ATP due to the aerobic metabolic cycle. Due to this muscle fibre leans more aerobic endurance capabilities. The muscle is often found in endurance athletes such as marathon runners, as they need to be able to run for long periods of time, so that they can do their exercise properly, and they need a lot of oxygen and mitochondria. They will need to train hard to get more of these type 1 muscle fibres. Type 2A. These type of muscle fibres are fast twitch muscle fibres. Type 2A are pink in colour. This is because they have some mitochondria and oxygen, but they don't have a lot of them. This means they can work for a bit of a duration time, but not as much as type 1 muscle fibres. They can split ATP at a fast rate. This means they can use both the aerobic energy systems and the anaerobic energy systems, but they mainly use the anaerobic energy systems due to them having less oxygen than the type 1 ones and more ability to use energy quickly. And this means that they can do fast, strong muscle contractions, however they fatigue more easily in type 1 because they don't have as much oxygen and mitochondria. These muscles will be used for events like rowing. This is because they need small amounts of oxygen but not too much. However, they do need to be able to do fast movements in order to have enough power to perform the rowing movements. Type 2B muscle fibres. These muscle fibres are white in colour. due to them having no oxygen and few numbers of mitochondria. They create ATP slowly, but they also break it down quickly. This will create short bursts of power which occur at this muscle fibre. This means that this muscle fibre will be used for sports which needs short bursts of energy, for example powerlifting. These muscle fibres can fatigue quickly because they don't have any oxygen, meaning that they use energy quite quickly when they get it. Sliding filament theory is the best way to describe and explain a muscle contraction. A myofibril makes up the muscle fibres, and this creates a sarcomere. This contains myofilaments called actin and myosin. The sarcomere is made up of both thick filaments and thin filaments. When your muscle cells are resting, the actin and myosin do not touch, but they try to pull together. Actin is blocked from getting to the myosin by two proteins called troponin and tropomyosin. The calcium is then attached to the troponin, and this causes the troponin to change shape, and it enables the tropomyosin to change shape as well. During this process, the myosin attaches to the ATP, which the muscle proteins use as energy, and this transforms into ADP, and this stretches the myosin out. As the troponin and tropomyosin is now out of the way, the energy on the actin and myosin allows them to connect together, and as the myosin pulls to the actin, it changes shape, making the whole sarcomere pull together. This causes a muscle contraction, and then after this, the myosin unbinds with the ADP, allowing another ATP to replace it on the myosin. And this causes the myosin to let go of the actin, meaning the sarcomere will go back into its previous shape, completing the whole contraction. Another part of muscle contraction will be agonistic pairs. In a muscle contraction, you have agonistic pairs that perform a muscle contraction. In these pairs, you have an agonistic muscle, antagonistic muscle, fixator muscle, and synergist muscle. An agonist muscle is the main muscle in a particular movement. This means that the agonist muscle is the one that's going to be contracting during the movement. And in order for this to happen, the antagonist muscle needs to relax. For example, if you tense your bicep to contract it, your tricep will need to relax in order for your bicep to be able to fully contract and flex up. This would often occur in things like a bicep curl, because that's where the tricep would be the antagonist, the bicep would be the agonist in order for it to complete this movement. In a agonistic pair, a fixator's main job is to maintain the body's posture during this exercise. For example, when you're doing a squat, your rectus abdominals are there to keep the posture of your body so that you complete the squat properly. A synergist muscle's job is to control a muscle's movement, enable it to actually do the movement properly. For example, the branchial radialis and the bicep work together in order to flex an arm in a bicep curl. Types of muscle contractions. Isometric. These muscle contractions occur when the length of the contracting muscle does not change. This often occurs when the weight of an object in front of you is the same weight as the object that is pulling the muscle down, with your muscles contracting in order to hold this object at the same level. An example of this is when you're holding up something like a tennis racket. In the hand there is no movement, however the muscle arm is contracting so that you have enough force to hold the racket steady. Concentric muscle contractions. This type of muscle contraction is the type of muscle contraction where the tension increases as the particular muscle shortens. An example of this would be if you did a bicep curl. As you raise the dumbbell, the tension will be put on the bicep as the bicep muscle will be shortened in this part of the exercise. Eccentric contraction. This type of muscle contraction occurs when tension is put on the muscle when it lengthens. This muscle contraction often occurs when the muscle is working against a force that is strong in itself. causing the muscle to lengthen as it contracts. Isokinetic contraction. This type of muscle contraction occurs when the muscle contracts and shortens at the same speed during the entire range of movement. This is very rare in sports because the contraction is hard to do. The best example of this would be a breaststroke, because you'll be continuously needing to contract at the same speed in order to keep swimming at the same speed in order to compete in the race. Compare and contrast the properties of muscle and muscle fibres. Skeletal muscle is involuntary. In contrast to this, cardiac muscle and smooth muscle are voluntary. This means that in order for you to use your skeletal muscle, you need your brain to think about using movement. Due to this, your brain will send signals to your muscle in order for you to complete a movement. Whereas with cardiac muscle and smooth muscle, it's voluntary, which means the body will just do it naturally for you, meaning that you don't have to think about doing these movements as they're important for your survival. These things will be like swallowing food or making your heart beat. Skeletal muscles are striated. In comparison to this, cardiac muscle is also striated. This means that the type of muscle has a sacrum that contracts whenever the muscle contracts. This will be in order to make a muscle contraction possible. So therefore, a skeletal muscle and a cardiac muscle would need to be striated in order to be able to contract and work how they're meant to work. In contrast to all of this, a smooth muscle is not striated. This means it doesn't need sacrum for its contractions and for them to work properly. Type 1 muscle fibres are mainly aerobic muscle fibres and use the aerobic energy system a lot more. In contrast to this, type 2A and type 2B use anaerobic energy a lot more. This means that type 1 muscle fibres use oxygen. The effect this has, it enables the body to exercise for long periods of time, as the aerobic energy system needs to work for long periods of time. Due to this, type 1 muscle fibres are common in marathon runners, as it is important that they can use oxygen efficiently and for long periods of time. Whereas type 2A and type 2B do not use oxygen. This means that the energy system will be used for quick short bursts of movement, as it can't work for long periods of time and it does not utilise oxygen. This means that those muscle fibres will be common in people that need more short bursts of energy, such as powerlifters, sprinters and maybe even rowers. Type 1 muscle fibres use ATP. In comparison to this, type 2A and type 2B also use ATP. This means that all these muscle fibres use ATP as it shows you that ATP can give energy to the muscles in order to be able to move how they're meant to during exercise, and so that they have enough energy to perform certain activities